Hello, my name is Marco Cordero, and I am in Mr. Melizer's B3 class, and today I'm going to be doing my video project on trigonometric equations and identities. So before we start, I'm going to go over some formulas that we're going to need for this first problem. So first we have the Pythagorean identity, and that says that if we have cosine squared theta plus sine squared theta, we can get 1 out of that. The next one is the double angle formula. This states that sine 2 theta is equal to 2 sine theta times cosine theta. This one's also special because if we have cosine 2 theta, we can use 3 different options. Our first option is cosine squared theta minus sine squared theta. The next one is 2 cosine squared theta minus 1. And the last one you can choose is 1 minus 2 sine squared theta. The last one that we're going to need for this one, the first problem, is tan theta is equal to sine theta over cosine theta. And another thing that we're going to be using for this first problem is the unit circle. Okay, now let's get into it. Okay, so the first problem says, let g of x equal 4.5 minus cosine 2 theta plus 6 sine, with a domain of 0 degrees through 360 degrees for theta. So what we're going to want to do is, so for A, we're going to show that g of x is equal to 2 sine squared theta plus 6 sine theta plus 3.5. So first we're going to look at our formula booklet, and we're going to see that, hey, we already have a cosine 2 theta, and we can see that we can use any of the 3 options. And since we don't have a sine squared, we're going to want to choose this one so that we can get the sine squared into that equation. So now all we have to do is plug it in. So it's 4.5 minus, and then we replace that cosine 2 theta with the 1 minus 2 sine squared theta plus 6 sine theta. Okay, so now we distribute the negative, and that'll give us 4.5 minus 1 plus 2 sine squared theta plus 6 sine theta. And now all we have to do is subtract the 1 from 4.5, and you'll see that we have our answer. So these are all the steps to show you that they are in fact equal to each other. Okay, there's the answer. Okay, so now that we have this answer, we have to find the exact value of g of x. And to do that, we're going to need to factor this answer that we got from the previous problem. So to factor, what you do is you take a times c. So you do 2 times 3.5, and that will get you to 7. Okay, and so now we come up with all the products of 7. And no, all the multiples of 7. And that's 1 times 7, and that's it. And then, so what can you do with 1 and 7 that will get you to b, which is 6? What you can do is you can do 7 plus negative 1. And so those are your 2 answers. So now we put it into factored form, which is going to look like 2 sine plus 7 times sine minus 1. And what we're going to do is set those both equal to 0. So we're going to have 2 sine plus 7 is equal to 0. Sine minus 1. Oh, don't forget these are thetas. Is equal to 0. Okay, so then all we have to do is solve for sine theta. And that's easy. Just subtract by 7 here. And then you have 2 sine theta is equal to negative 7. And then that's easy. Just divide negative 7 by 2, and you have sine theta is equal to negative 7/2. But the problem with this is that it is greater than 1. And you can't have a number with an absolute 0 of greater than 1 as one of your values. So we know that, because that's, the unit circle doesn't go over a number of absolute 0, absolute value of over than 0. So then we know that this isn't an answer. So then we go over to our other one, and we see that sine theta is equal to 1 just from subtracting. And if we look on our unit circle for where 1 is, we'll see that 1 for sine is at 90 degrees. And we know to use degrees instead of radians because our domain is in degrees. So our final answer comes out to 90 degrees. Okay, so now we go on to question 2. Okay. The height h meters of a seat on a Ferris wheel after t minutes is given by h of t is equal to 10 sine with 0.5x minus pi over 2 plus 10. So for A, we have to find when t is 0. So this is very easy. All we have to do is just put 0 at the end of it and set it equal to 0, like this. Okay, so our first step is to subtract 10. So A is going to equal negative 10 plus 10 sine 0.5x minus pi over 2. Okay, so then what we do is divide by 10. So now we have negative 1 is equal to sine 0.5x minus pi over 2. And so this is when we need to use the calculator, because we do the inverse of sine of negative 1. So I'm going to plug that into the calculator. Inverse of sine is equal to negative 1. And that'll give us negative 1.57. So we know that negative 1.57 is equal to pi over 2, because pi is equal to 3.14, and we can tell that 1.57 is half of pi. So we can just say, to make it easier, pi over 2, negative pi over 2, because that's a negative number, is equal to 0.5x minus pi over 2. Okay, kind of running out of room, but so now all we have to do to cancel that out is to add the pi over 2 to the other side. So that just equals 0 is equal to 0.5x, and we know that nothing can be divided by 0 because that doesn't give you anything. So we know that x is equal to 0. So when t is 0, your height is 0. So when you're at 0 minutes, you're at a height of 0 meters. Okay, so next we have to find when h is 15. So when you're at a height of 15 meters. Now, the second method of solving something like this is to just put it into your calculator. So what you do is you go to y equals, and then I already pre-typed it out, but you do the equation, which is right there, and then you do 10 sine like that, and then you put what you want to get right here. And then all you have to do is go to graph, and it's already graphed out. And then what you do is go to trace, and then intersect. And then you choose your first curve, which is this one, choose your second curve, which is this one, and then you guess where it's going to be, which is going to be somewhere right there. And that is all you have to do, and then it gives you the answer of when y will be 15, x will be 4.18. So when h is 15, t will be 4.18. That is the second method. So now you know two methods. You could set it up like this, or you could set it up like that. So now that we know that, we go on to C. How many minutes will it take to complete a revolution? So basically what this is asking you to do is find your period. And to find the period, it's pretty easy. All you have to do is take your b value, which is 0.5 in this case, and you put it under 2 pi, which we can see in our formula booklet. We can see that this is your b value, the 0.5 is your b value, and to find the period, you put your b under 2 pi. So you put 2 pi under b, and that is just equal to 4 pi. So now you know that it takes 4 pi, which is around, if you put it into your calculator, it'll take around 12 minutes, 12.5 minutes to complete a full revolution. Okay, so now we go on to problem D. Graph h of t with a domain of 0 through 8 pi. Okay, so using everything that we learned from the first one, this should be easy to graph. So we know that it starts at 10, and it has an amplitude of 10. So that means our y-axis will have a minimum of 0 and a maximum of 20. So let's just graph this out here. This is 20, and if we go by 2's, it'll be 18, 16, 14, 12, 10, 8, 6, 4, 2, 0. Okay, so that is your 0. And then for our x-axis, we're going to want to go by radians, because that's going to make it a lot easier. So let's make it where every 4 is a pi. No, let's make it, yeah. So pi over 2, pi, 3 pi over 2, 2 pi, and then do that all the way up to 8 pi. 5 pi over 2, 3 pi, 7 pi over 2, 4 pi. Oh, am I gonna run out of room? 9 pi over 2, 5 pi over 2, not over 2, 11 pi, 2, 6 pi. I'm actually gonna run out of room for this. Okay. And then we have 7 pi right here. Okay, so we know that it starts at 0, 0 because of A. So we know that the first point is going to be right here. And we know that it does a full revolution after 4 pi. So we know that it's going to stop over here. And we know that in between that is where the maximum point is going to be. So that's 2 pi. And then, so that is right here. Oop, let me line this up. Bam. That is our maximum point. So then we know that we can just go like this. Ooh, and we know that our midline is going to be 10. Just want to mark that like this with dashed lines. Okay. So we just draw like this. It's a pretty not so good graph, but it's good enough. And then we know that our second maximum point will be at 6. And then we'll know that our last point would have been at 8 pi, but we can't graph that because it's off the graph. And this is your graph for your first problem, or for the problem. And that is the end of the video, and thank you and enjoy the rest of your day.